All right, so today we again are going to be continuing area between curves, day 2. So today we're going to be looking at situations like we see on that general form there. So if we look at that first figure, we see the region bound by the curves of f of x and g of x. However, do we just have one shaded region? How many shaded regions are there? 2. Could it be possible that I have more than 2? Sure. Okay. I want you guys to think about how would we express, think about what we did on Friday, how could we express the area of those shaded regions? All right? So think about that, talk about it in your groups. If you have an idea, go ahead and write it down on the line. What would we do to express the area of our regions? All right, everybody. A lot of good thinking out there. Thank you for taking some time to think. So let's talk about it together as a class. So most of you, I think, came up with the idea. We have 2 regions, right? A lot of times you'll see this as, hey, let's call this region, except not with the highlighter. Let's call this region R and this region S. What would we need to do with those 2 regions? Add the areas. If we know the area of both, can't we just add them and get a total area? Makes sense, right? So total area is going to be both of those regions added together. How can we express maybe that region for just R? How would we express the area for region R? Let's go with Josh.
The integral from A to B.
Let me do it. Well, no, I think I can still do it. A to B.
Yeah. G of x minus f of x dx.
Why G first?
Because G is the top one.
G is the top. So you need to pay attention what is on the top, what is on the bottom. And in this case, G is on the top, F is on the bottom. Okay, how would we express the area for S? So for our region S, how would we express the area for that one? Go with Matthew.
The integral from A to B.
Is it A to B still?
Or B to C.
B to C.
F of x minus g of x dx.
Now, there was a few of you that expressed it in like 4 different integrals, and that's fine. But we do want to see if we can consolidate things if possible. So then I just need to add those 2 together, correct? So, couple things that you have to pay attention to. The interval of integration. Some of you are trying to use the f of a, f of b, f of c. We don't use that here, just the a, b, and c. Okay, so we're going from a to b and then b to c. That's our intervals of integration. Second thing that you have to pay attention to, what function is on the top? Because remember, it's always top minus bottom. And so in this case, we had g was on the top first over here, but then it flipped, and f became on the top on the second region S. So how do we express that? Well, we would just say all together that this is the integral from a to b. Again, g is on the top first, g of x minus f of x dx. And then we add that to our second region, b to c. And this time, f and g have flipped. So we need to make sure we do that. F is on the top. Now g is on the bottom. dx. Okay? So that is how we would express the area of the 2 regions combined, R and S. Okay? All right. So with that in mind, I want you to try that first problem. Okay, ladies and gentlemen, I've given some help. I haven't set up any integrals yet, but go ahead and look at what I have up there and see how it can help you move forward. All right. Seen a couple people get 16. Is that what we're getting out there?
Yeah.
Okay. Let's just write the setup. Make sure we're all getting the correct setup. And then, yes, calculators, you can do it. This one is an example of a problem that could be done by hand. It's not too complicated. I was able to work out my intersections by hand. And these are both just polynomials. So these would work out that we could actually do this by hand. So this could be a problem that you might be asked to do by hand. Obviously, I'm saying you can use your calculator, but note that you might be asked to do some of these by hand. Okay? The next problem, problem 2, is obviously one with calculator. Yes?
When given a problem use, would it be like easier to start off by taking the antiderivative and then starting the problem? So that way, like start like.
Oh, I see what you mean. So you have everything there, I guess. But let me just show you. Let me get it filled out, and then I'll show you that you can actually simplify things before taking the integral, and it might help you out. Right? All right. So let's see. We are doing the first area, so that'd be the integral from -2 to 0, and our f is on top. So that's going to be x squared plus 4x, and then that would be minus our g of x. So that would be 12x plus x squared minus 2x cubed dx. And then we are adding that to our integral from 0 to 2. This time, though, our g is on top. So that's going to be 12x plus x squared minus 2x cubed minus my f is on bottom. So that will be x squared plus 4x dx. Don't forget your dx's. They are part of your integral, and you might lose points on an f or q for not having the correct setup within the integral. Okay? So just be careful with that. Now, to answer your question, Jalen, what we can do, if you were to do this by hand, I would simplify your integrand first. So I would say, hey, I have that negative. I can distribute it. And I can simplify my integral from -2 to 0 to be my x squareds cancel. And 4x minus 12x would be -8x. And then that would become plus 2x cubed. That's a lot less that you would have to do inside your integral now, right? So you can simplify. If you're asked to do this by hand, try simplifying things before actually doing the antiderivative, okay? As then you would have less work. And then same thing on the other one. The x squareds again cancel. And I have 12 minus 4. So that would become positive 8x minus 2x cubed. And actually, I can notice something here. Well, maybe we can't do that here because our intervals are different. So we'll just leave that as that. But I would definitely, if you're doing this by hand, simplify things. Okay? All right. I know some of you have already started, but if you haven't, go ahead and start looking at problem 2. Any questions on problem 1? Okay. Problem 2 is definitely a calculator. So use your calculator to find your intersections, please. Let's go ahead and look at this one. It is definitely a calculator problem, so we want to get our calculator out here ready to go. So we need to graph our two functions. So we'll go ahead and do that. You should have done that already. And remember, you can always change your window to better see the functions. Right now I'm going to go ahead and just put it at 6 standard, and then I'll zoom in as needed. All right, so I'm going to go ahead and have my first one, 1 plus 2x plus e to the negative 2x, except I didn't do my power, so let me go ahead and get my power. There we go, negative 2x. All right, and then I have my, also I want to show you something that's really neat. Once you've assigned them into here, let me get this one in here so that you don't actually have to type out all these integrals in your calculator. It makes it actually something very nice. Minus 6.5x squared plus 6x plus 2. And I think I've shown you this before, but I'll show it to you again. All right. So ours or mine is getting graphed here. Okay. So I do need my bounds, but I want to show you something that's actually really nice. Is that I can use my y1, y2 here so that I don't have to retype these into my integral when I do my integral. So my first one, those of you that actually have calculated, what are the bounds? I know we're starting at 0. Where do we intersect here? 8601. I'll just take that. All right, what is our last intersection point? What is that? Okay. Now, we know our first integral is going to be the integral from 0 to 0.8601. And that's going to be my first my top function. What's my top function for that interval? The g of x. My g of x is going to be the top. So I know I'm going to be doing g minus, and then what's my bottom function? F of x in this one. So I can do g minus f. Or in terms of our calculator, my g is y2, and my f is y1. So I can actually, if I go out to here and I do my integral, there is also another way. I don't know how, but I have seen it done that you can actually store the intersection points that the graph gives you. You can store it as a variable. I would have to look that one up. I don't know how it is done. I know it can be done. I just don't know how. So I'm just going to go ahead and put them in as I see them. So that's 0.8601. But I want to show you this. I do know how. That instead of having to type out all of g minus all of f, since I already defined them in my y-vars as y1 and y2, I can just recall that, say alpha and then this button here, and I get y2 minus y1. And then I can integrate. And there's my first area. I'll show you again how that's done. At least on the TIs. On the Casios, it's done in a slightly different way. Okay, so again, how do you get that? On the TIs, you click alpha and then F4. And that will give you your y variables. On the Casio, I think you actually type it in, y1. It's a lot easier. Yeah. Go get your y and then go y1, and you're recalling it.
Here.
Okay, so that's only half. We need to do the other half. So I'm going to go ahead. I'm also going to store this into a variable so I have all my decimal places. So I'm going to go ahead and say, hey, I'm going to store this as, let's do A and B. I'm going to store this as A. Okay, and then I'm going to do my integral from 0.8601 to 2.0876. And this time, F is on top, and G is on bottom. And again, on mine, I have them assigned as G is F2, Y2. So this one's going to be Y1 minus Y2 for me. Okay, you have to pay attention to how you assigned yours. So I'm going to go ahead and do that here now. So that's going to be 0.8601 and then 2.0876. And again, so I don't have to type everything in, I'm just going to do y1 minus y2 this time. So y1 minus y2. And don't forget to put the dx. All right, so that is 2.1155. And then I add those together, so I'm going to go ahead and say plus what I had stored in A. So that should be final answer 2.760. That's what I'm getting anyways. Okay, ladies and gentlemen, I know we don't have a ton of time. Let's at least get this set up down here. Okay, what do we notice about problem 3?
Why should
It needs to be in terms of y. Our first one already is, and that is going to be my red curve. Okay? That isn't, because I see it's a quadratic and my red is a quadratic, so this is going to be my red curve.
Can we just write that as f of y?
You can definitely write it as f of y if you want to. Okay. And then my next one is going to be my blue curve. Is my blue curve in terms of y?
No. But x equals 6y, or negative 6y.
But I can easily solve, multiply both sides by negative 6. So we have x equals negative 6y. That is going to be my linear function here. Now, when we do our bounds, we go the lower number to the top number. So what would be my first integral? Integral of what? From where to where? 1 to 2. Okay, so this is going to be my first area here. Now, when I write it out in terms of y, it is not top minus bottom. What is it?
Left minus right.
Right minus left. Right minus left. Okay, right minus left. Positive minus the negative. Okay, so it's going to be my blue function, negative 6y, minus my red function of 6y squared minus 18y dx. Okay, how am I going to write out my integral for the second area? What's my bounds? 2 to 3. And then, yes, those get flipped, because what's on the right this time? The red function, right? My 6y squared minus 18y, except I used pink instead of red, but close enough. And then that would be minus my blue function negative 6y. All right. Make sure you get the answer to that one. Your homework is on College Board, I believe. Have a wonderful day, everybody. And we'll see each other tomorrow.